Welcome to this short video on FFT, fast Fourier transform, the implementation of fast Fourier transform using a butterfly algorithm. So let's try to draw 8-point FFT butterfly diagram in short steps. So the first step is, we have to find the exact sequence or the correct sequence of the input samples. And this process, this can be done by a method called bit reversal. So in this case, we are going to start with the original bit sequence from 0 to 7, and we'll try to do the reverse bit reversal. So bit reversal is a simple process. What we're trying to do, we just want to rotate the existing bits. So 0 0 0 doesn't make any difference. So it's going to be 0 0 0. If it is 0 0 1, then this 1 will take the place of 0, and this 0 and this 1 will displace. So accordingly, you will get the answer 1 0 0. So 1 0 0 is nothing but 4. So this is supposed to be 0, and here we will get what? 1 0 0, that is equal to 4. Similarly, if it is 0 1 0 0 1 0, this will take this place 0, so this will be 0, and this will move here and this will move here, so which will make 0 0 1. This is nothing but 1. Similarly, we can also find the bit reversal for 0 1 1, that is 1 0 1, which is 5. 1 0 0, that's become 0 1 0. 1 0 1 1 1 0. 1 1 0 become 0 1 1. 1 1 and 1 1. So we got the sequence now, the bit reversal sequence: 0 4, then 1 5, then 2 6, and 3 7. These are acting as the input sequence. So we have to draw the start with the FFT butterfly diagram with this particular sequence. Okay, that is the first step. So we can draw now 8 lines, the sequence as we have explained in the previous slide. So we have x of 0, x of 4, x of 1, x of 5, x of 2, x of 6, x of 3, and x of 7. Now we are going to do a decomposition. So we are going to do, first is what the n by 2 decomposition. So in this step, we are going to do first, the 2-point DFT, sorry, 2-point FFT. We are going to do 2-point FFT, followed by 4-point FFT, then 8-point FFT. So this is the procedure. So we start with 2, then 4, then 8. So 2 inputs we have to consider at a time. Okay, then the next stage, 4 inputs will be considered. The following stage will have 8, the inputs. So to do the 2-point FFT, so this is basically a 2-point FFT. We have to consider 2 lines at a time, and this factor, the diagonal one, is normally a multiplication factor of 1, and this factor is the multiplication factor of -1, and the same process will continue for the rest of the pairs. So likewise, we can complete all the pairs, like 2 lines, the first 2 lines, the second 2 lines, third 2 lines, and fourth 2 lines. So this is called the 2-point FFT implementation. Then we are going to mark the output at this particular stage. We are just marking these outputs are P0 P1, Q0 Q1, B0 B1, and C0 C1. In the next stage, we are going to do the 4-point FFT, considering 4 lines at a time. We are going to do the same butterfly connections for the first 4 lines and the second 4 lines. So this is going to be 4-point FFT. So where the 4 lines are connected, the first 4 and the second 4, and the corresponding coefficients are W4 to the power 0, W4 to the power 1, W4 to the power 2, W4 to the power 3. Why it is 4? Because this is, we are doing the 4-point, this particular stage we are doing the 4-point FFT. The same process will continue for the lower 4. So now we have the lower 4 also. The coefficients are exactly same as the previous one. We follow W40, 41, 42 and W43. Okay, so this is the second stage. Now we want to mark the output at this particular stage. Now, so we mark the upper 4 as G0, G1, G2, G3 and the lower 4 H0, H1, H2 and H3. In the next stage, we are going to use the 8-point FFT by connecting the 8 lines, okay, by the intersections, okay, like a butterfly diagram. So we are going to connect from the top 4 to the bottom 4 in this in this way. We are going to connect the same manner the lower 4, so it should be connected with the upper 4s. So now we found the 8-point FFT. Better we got it. Or the 8-point DFT we got it. So now we have the 4 levels, the 2-point FFT, sorry, 2-point DFT, 4-point DFT, 8-point DFT. Okay. Now the output we have the 8 outputs, and this output is going to be the actual the Fourier transform the samples or the sequences. Now the coefficients are the upper 4. We are starting with W80, W81, W82, W83. Why we are using is 8 here, because this is the part of the 8-point DFT. So the final coefficients are from W8 power 0 to W8 power 7. The output are respectively the same order, the normal order, the regular sequence, which is x0, x1, x2 up to x7. So this is going to be the output sequence, x of 0. So the output sequence are respectively x0, x1, x2, x3, x4 and up to x7. Okay. Now we have to find out the value, the expression for each of this intermediate input. For example, after the 2-point DFT, we want to find out the value of P0 P1, Q0 Q1, B0 B1, C0 C1. Same way G0 G1 G2 G3, X0 H1 H2 H3 and finally X0. Now these coefficients W to the power W 4 to the power 0, W8 to the power 0, these are basically called as the Tweedle factors, and these Tweedle factors you can find out from the standard table the values of the Tweedle factors for each of these endpoint DFTs we can calculate directly from the table. This is a standard table is available, so you can use the standard table and get the corresponding values. Now let us try to find out the values of P0. So the P0 value, the P0 is exactly at this particular node, and this particular node we have the P0. To get the P0, X0 and the X0 and X4 is going to be added. The coefficient is 1, so it's nothing but X0 plus X4. Now to find out the value of P1 we have this coefficient -1, so X0 will be positive but X4 is -1 multiplied by -1, so the answer is going to be P1 is equal to X0 minus X4. The same manner we can also calculate the values of Q0 Q1, B0 B1 and C0 C. So these are the values of Q0 and Q1. The same way we have calculated P0 P1, we can find the values of Q0 and Q1. So we'll have Q1 x1 plus x5 and x1 minus x5. Next stage we are going to find out the value of B0 B1, C0 and C1. So now we can find the values of B0 B1 and C0 C1 using the same method. Next stage we are going to find out G0 G1 G2 G3 and H0 H1 H2 and H3. So G0 is obtained by G0 at this particular node. It is obtained by adding P0 and the Q0, and we have a factor W0. So P0 is direct, but Q0 multiplied by W4 to the power 0. So since W4 power 0 is 1, so it is simply add P0 and Q0 to get G0. To get the value of G1, to get the G1, P1 direct and Q1 through or multiply by a factor W4 to the power 1, which is a two-real factor. We can find the value from the table. And so in this case, G1 is equal to what? P1 plus W4 to the power 1 Q1. And to find the value of G2, this node is G2. So here, P0 is direct, whereas Q0 multiplied by W4 square, which is again another trivial factor whose values can be obtained directly from the table. So this will give you G2, that is equal to P0 direct plus W4 square times Q0. G3 is obtained by P1 plus W4 to the power 3 Q1. Again, the factor W4 we can find out from the table. So in the similar manner, we can find out the value of H0, H1, H2 and H3. So we have these coefficients W4 1, W4 2 and W4 to the power 3. And the last step is we have to find out the value of the final values, which are X0, X1, X2, X3. These are the final outputs. Now to get the final output X0, we are getting G0 direct, and we are also getting another input is the H of 0 multiplied by W8 to the power 0, which is 1. So it is something but simple addition of G0 and H0. So same way you can calculate the value of X of 1. X of 1, G of 1 direct, whereas the H of 1 is to be multiplied by W8 to the power 1 H of 1. And the same process, in the same manner, we can calculate the other values of X2, X3, etc. up to X7. So X0 is equal to G0 plus H0, X of 1 is equal to G1 plus W8 H1, X2 is equal to G2 plus W8 square H2, X of 3 is equal to G of 3 plus W8 cube H3, X of 4 is equal to, so remember in the case of X of 4, the H of, because we have up to H of 3, and what's going to happen, the next level, which is basically rotation. So which means that after H of 3, the same sequence will be repeated, like H of 0, H of 1, H of 2 and H of 3. So X of 4 is equal to G0 plus W8 power 4 plus the H of the rotated value, which is H of 0. And finally we can get the value of X of 5, X of 6 and finally X of 7, that is equal to G of 3 plus W8 to the power 7 H of 3. Now how to find the two-digital factor? So the two-digital factor is defined as Wn to the power k, and the basic equation is Wn to the power k is obtained by the relation e to the power minus j 2 pi by n times k. Now if you substitute k is equal to 0, then we will get Wn to the power 1, and which is equal to, Wn to the power 0, which is equal to 1, and Wn to the power Wn to the power 1, or if the value of k is equal to 1, then you will have an equation e raised to minus j 2 pi by n. If you substitute for n, for example in the case of n point FFT, normally we apply n is equal to 8, so W8 to the power 1, it is nothing but e to the power minus j 2 pi by 8, which is e to the power minus j pi by 4. And by expanding by the Euler's rule, cos pi by 4 minus j sin pi by 4, if you calculate the values, it will be about 0.707 minus j root 7 0.707. So by applying this manner, you will be able to find out the other values of W, the trivial factors such as W8 power 2. So if you calculate, this will be what minus j, and W8 power 3, this will be again minus 1 by root 2 minus j 1 by root 2, and same way you can calculate the other values. Then W8 power 7 will get 1j, which is j. So likewise you will be able to find out all other values using the basic equation of the trivial factor W and k is equal to e raised to minus j 2 pi by nk. And this tutility factor is one of the important component of the FFT calculation. Thank you.